Hi everybody, welcome to TIA Now. I'm Clarence Reynolds. Researchers need city-sized playgrounds in order to properly test and deploy 5G technologies, and that's why the National Science Foundation has announced that it will deploy 2 platforms for advanced wireless research. Dr. Tiaga Nandagopal is the Deputy Division Director of the Computing and Communications Foundation Division at the NSF, and he joins us with a tale of 2 5G cities. Welcome, Dr. Nandagopal.
Thank you for having me here, Clarence.
Absolutely. Yeah. Why was it important for the National Science Foundation to deploy the test beds through an entire city instead of smaller control areas?
Right. So one of the things that we have done in the last 20 years is we have figured out how to do things in a lab. Right. So we can have small prototypes, we can build them, fabricate them, build small systems and whatnot, and try to test them and see if it works in a lab in a small scale. However, the challenge is often people then want to take them just because they work in a lab, they think it works everywhere. And the barrier from there to like a full-scale deployment is things can fail in real world. Real world throws up a lot of surprises. And that's where many technologies fail, what we call the valley of death. And we want to ensure that we don't trip up there, especially with 5G, where there's a whole bunch of technologies that are coming up that have a whole lot of potential. We want to be able to explore all of them. And that's why we are focused on building a city-scale test beds as part of this program.
Now the tests are going to be both in Salt Lake City, Utah, and in New York City.
Right.
Are those tests going to be the same?
No. So we have planned 4 different cities. The first 2 have been announced in the last 2 weeks. The other 2 will be announced later. But the technologies that are part of each of these locations are completely different. There may be some overlap between these. So for example, the Salt Lake City testbed focuses on dynamic spectrum and massive MIMO technologies, and one in New York City focused on, to some extent, advanced wireless technologies that include some dynamic spectrum, but also heavily focused on millimeter wave technologies, which is about 25 gigahertz, which is all the rage right now as well. So some overlap, but not necessarily the same. So we want to ensure some diversity of topics, so people can just go around and pick the ones that are best suited for their thing.
And what kind of 5G applications are we going to see tested on these platforms?
Now that's like a whole slew of things, right? Have your pick. So we can start with drone deliveries, autonomous vehicles, AR, augmented reality, virtual reality as you move around. This is not just your indoor augmented reality. This is like when you walk in a city street, you have information coming up on your augmented headgear that kind of shows you what information about things. We have smart healthcare delivery, sensors, city scale sensing, all kinds of stuff, right? And also, I mean, the good thing that we always want to have is help with our fire and rescue first responders who can get instant information on what's happening around and get to the destination or provide the services they need to do on a real-time basis.
Now, are the tests that are happening in New York and Salt Lake City, are they going to be the same kinds of tests that were deployed before previous generations of technology, 5G, wireless technology?
So if you look at the basic wireless level, we are going to be doing similar things, channel testing, deploy an equipment and see how it performs, how much throughput you get, what's the latency you get. At some basic level, conceptually they are similar, right? But what is going to be different though is how they all come together, right? So because it's a city scale, you're displaying an end-to-end network, right? You're not just deploying the radio frequency equipment, you're deploying the base stations, you're deploying the network behind it, as well as the routers and the applications even. So you're going to be able to test a full-fledged application all the way end-to-end, and you can customize anything, any of these things. That's the beauty of this whole thing. They are completely programmable. You can customize however you want. And that's the thing that sets this apart from everything we have done in the past before.
Now, some carriers have said that they are planning to make their 5G deployments by the end of 2018. Will these tests compete or interfere with those deployments?
That's an interesting question, right? So there's always been a concern, oh, this 5G going to be done, right? The way we see it, and I know if you look at the way this 5G standards are playing out, we have one set of standards coming up, release 15, and then release 16 will come out in a few years, and then release 17 and so on. Each of them are progressively trying to advance the technology, right? So what we are seeing right now is the initial phase, and that's what the carriers are going to deploy right now. The good news about this is these very carriers are part of the industry consortium that's helping build these testbeds too. So what we are expecting and are going to see is the lessons from the early carrier deployments percolating into the design of these testbeds. And then when the testbeds get up and running, everybody learns from this, the industry consortium, the entire research community learns from this, is going to percolate into the next set of rollouts. So it's a synergistic process, that can be feedback back and forth between the actual live deployments and the test beds themselves.
And how long will the NSF deployments be in place?
So the deployments that we are putting out right now, the Salt Lake City and the one in New York City, are going to be for a 5-year period, starting this year. That's how much the NSF funding is going to last. But however, if you look at the history of these test beds and the amount of industry interest in using these test beds, we have a plan to keep them sustained for another 10 years or so, which should allow us to test everything that comes in 5G and beyond 5G as well.
And are there similar tests happening around the world that are the same kind of deployments for testing?
So if there are some test beds around the world, I would say notably call out the 2 test beds, one in Finland in Oulu, and then one in Bristol in the United Kingdom. So these are 5G test beds, right? So we have been a little bit, so while we are similar in scope to some extent in the first year or so, we are planning beyond 5G. We are looking at the ecosystem outside of 5G, the Wi-Fi, the LoRa, and the other kinds of networks that may come, all wireless, right? But we're also thinking about what will happen beyond 5G, right? So we're looking, whether you want to call it 6G or however you want to phrase it, but we think there is a world of devices and wireless systems that's going to happen after this, and we are making sure that this test bed that we are building will be the foundation for anything that we want to explore around these topics.
Overall, what is the NSF hoping to learn from these test deployments?
So I want to take you guys back a little bit, right? So if we are old enough to remember how life was 20 years ago, right? So this was like when we used dial-up modems, right? The internet didn't exist in the way we knew it, right? DSL connections were something they are unheard of. And in 20 years, there's a company called Qualcomm that came up, right? And with NSF support, I may add, we funded that company, and they launched and they went big with what we call a CDMA that kind of brought cell phones to the mainstream. And then there's a company called Google that we funded, and there's this thing called a smartphone. Now, if you look at the technologies that go behind a smartphone, Apple didn't invent it right off the bat. The touchscreen, the GPS systems that were in there, the user interfaces, all of them came from NSF-funded research, right? So, but when the smartphone came about, it changed our entire way of life. Companies such as Uber and Facebook would not even exist without the smartphone right now, right? So what we are thinking about this, we are investing in basic research, and the goal is to help create this unseen, unforeseen technologies that can fundamentally change how we think, how we live, and how we interact. And the side effect of that is we have been able to maintain our predominant position in the world economy by creating these new digital economies, right? And that's, if you look at what's happened in the last 20 years, that's been the hallmark of the world economy, the entire shift from analog to digital. And we have been seen as the leaders in the whole thing. And NSF is proud to be behind each one of those investments. By continuing this program, the Platforms for Advanced Wireless Research, and creating these test beds, we are hoping to launch the next generation of entrepreneurs who will capitalize the technologies that come from these, that will be tested on these platforms, and maintain our economic superiority and technological leadership for many years to come.
Excellent.
Yeah.
Well, Dr. Nandagopal, thank you for being with us today.
I appreciate it, and thank you I want to also congratulate and appreciate the TIA's partnership. So they are partners of this 28-member industry consortium that's helping build this platforms. So I really commend you guys on your foresight and help and with us on this effort.
Thank you very much.
Thank you.
And also thank you for watching, and we'd like to hear from you, so you can reach out to us on Facebook or Twitter, and you can also see more videos at tianow.org and on our YouTube channel. Thanks for watching.